Alrighty, and then moving on to example 3 on the back. So a small company produces greeting cards. How sweet. The cost in dollars of producing N greeting cards per month can be modeled by the function they give us here. C equals 360 plus 0.6N. I want to find the inverse and then use this model to find the number of greeting cards produced in a month in which the company's total cost to produce the cards was $615. Okay. Now, remember that when we find an inverse, we swap x and y and then solve for y. That's only because our x always is our input. However, when we have input and output variables that actually stand for real things, aka if you have a word problem, you can't just swap your x and y, or in this case, n and c. You can only do that when you're talking about generic functions. When you have a word problem, do not swap x and y, or do not swap the variables in general. Do not swap the variables, because this time they actually stand for something. And so this equation they give us cannot be changed. It can, however, be rearranged. So if we start with c equals 360 plus 0.6n, all we do is we just solve for our other variable. So we solve for n. So then what we do, if I'm going to find n, I need to get rid of this 360 and this 0.6. The 360 has to go first, so I subtract it from both sides. So c minus 360 equals 0.6n, and then to solve, we should divide by that 0.6. So now we have n by itself, and it's just equal to c minus 360 divided by 0.6. Now, if you wanted to distribute that divide like we did on f of x up above, f inverse, excuse me, you totally may. You don't have to, though. This is good enough for me. And then, so we found our inverse. Cool. Then use this model to find the number of greeting cards produced in a month in which the company's total cost to produce, okay, total cost, there it is, to produce the cards was $615. So what we do is we swap out our cost variable with 615. Well, naturally, that's C for cost. So I have n equals 615 minus 360 over 0.6. We want to do that subtraction first. 615 minus 360, that is 255, divided by 0.6, that gets us 425. Now, what did N stand for? Oh, N greeting cards. So apparently, if they sold, or excuse me, if their cost was $615, that means that they made and or sold 425 cards. Cool. Now, the next idea we have is what's called the horizontal line test. This is slightly different from what we've heard of before. We've used the vertical line test to determine if a relation is a function, right? If I give you a graph and I give you this funky thing going on and I say, hey, is that guy a function? Well, you would draw vertical lines. If it passes your function in your relation, your graph, in more than one spot on any given vertical line, then that means that it's not a function. Now, remember that our graph, our inverse graph, is a reflection across the diagonal line y equals x. So we use this time what's called the horizontal line test. So if I give you a graph and I give you something that looks like that, we want to draw horizontal lines. And if our horizontal line hits our graph at any given point more than once, that means that its inverse is not a function. So the pink graph that I drew still is a function, but its inverse will not be. It'll just be an inverse relation. So we are going to go ahead and pull example 4a and 4b up on our graphing calculator and take a look at those graphs. Alrighty, so I've got f of x from example 4a plugged into my graphing calculator and my y equals. And then let's take a look at our window real speedy quick. So I played around with this and was just able to find a good viewing window. You can play around with it and see if you can find one that looks a little bit better. But I came up with -5 to 8 on our x windows, -60 to 20 on our y's, so that our graph looks like this, and we can see the nice smooth curve, all the hills and valleys, etc. So we are going to include a sketch of this on our graph, or on our notes, and whenever you're pulling up a picture using your graphing calculator, make sure you include a sketch. So remember that we are using our horizontal line test to determine if the inverse is also a function. Well, if I draw a horizontal line down here we're fine, right? At that last tick mark, we're fine. But the horizontal line test says that you have to be able to draw a horizontal line anywhere. So notice if I draw in a horizontal line anywhere between like that mountain and that valley, then it's going to hit it in multiple spots, right? So this guy fails the horizontal line test. So that means that its inverse is not a function. Alrighty, and then example B, I went to my y equals and this time typed in 2x cubed plus 9. Again, I've already found a good window to fit -3 to 3 on our x, -3 to 15 on our y. So when we pull up our graph, we get this nice looking curve. Now, it looks like things get a little dicey right there, right? Like to me, that looks like a horizontal line. So what we can do is we can zoom in to see whether or not it actually is. So we'll go to zoom, option 2, zoom in, and then we want to arrow up to the ordered pair 0, about 9-ish. I mean, it can't be exact. Now, how do I know that that point is 9? Think about your function. Y equals, or g of x equals 2x cubed plus 9. If I plugged in 0 for x, I would just get out y equals 9. Or yeah, so then my y-intercept would be up at 9. So I zoom in. Oops, that's not what I wanted. Zoom to zoom in, enter. And then it looks like I'm still kind of getting this horizontal line. But if you hit trace and then you arrow left and right, so if I arrow to the left, it looks like for sure past this maybe horizontal line, things are decreasing. And to the right of it, it looks like things are increasing. So what I expect to happen, what I want to happen, is for y coordinates to decrease as I move to the left. And sure enough, yeah, there's a whole bunch of 8.999s, but they are still technically getting smaller, very slowly, but they are getting smaller. So as I move from left to right, all of my y coordinates are getting bigger, so they're never exactly the same, which means this guy does pass the horizontal line test, meaning its inverse is a function. Our instructions ask us to go ahead and find out what that equation is, so we'll go back to our notes to do so. Okay, so first of all, note I went ahead and drew in some sketches of our graphs for 4A and 4B, and I also noted that 4A fails our horizontal line test, our HLT. So what we know from that is that our inverse is not a function. That's not to say it doesn't exist, that's just to say that it's a plain old relation. It's not a function, right? But then in example B, our graph passes our horizontal line test, so that means that our inverse is a function. So let's go ahead and find out what it is. So instead of g of x equals 2x cubed plus 9, we're going to call it y equals 2x cubed plus 9. Because remember, the first step of finding an inverse function is you swap x and y. So you have x equals 2y cubed plus 9. Then you want to solve for y. So you subtract 9 from both sides, equals 2y cubed. We divide both sides by 2. So we have y cubed equals x minus 9 over 2. And then to undo cubing something, we take the cubed root, right? So we have y equals the cubed root of x minus 9 over 2. And remember that instead of y, you can call it f inverse of x is how we read that.